that even though a function may fail the horizontal line test, if you cut its domain properly, you can still have an inverse function. Because look, that passes both the vertical and horizontal line test. So that has an inverse. Okay. All right, you ready for the hard one? The one that's... Yeah, we're going to do what, 2x over 3x minus 1. You want to try it first? No?
Sure, why not?
Do you all want to try it? Yes? Okay. I'm not saying it's like crazy impossible. It's just, it's messy. But I put a star next to this because if I ask you to find the inverse of a function, this is most likely what you're going to see. Because there's algebra in here that is good stuff. It's good algebra in here. I'm curious to see if anyone can get it. I don't know why I like that sneeze so much. It's kind of weird. I'm missing something.
By itself. There's two right there. We need to try and like combine them somehow. What I'm thinking is, I got it. This. 3y minus 2y. Yeah. And then you can get rid of that x by dividing by x.
You're on the right track. Don't divide by x, though.
Don't divide by x.
Read what you have.
All right, I have 3yx minus 2y equals x.
You're trying to solve for what? Mm-mm.
Why? Yeah. Now I said what I got. Oh, divide by y.
You're almost there.
Okay, so right now I'm at like
I need to
3x
figure,
y
I need to
minus
figure out
x
how to get
equals
rid of the
2y.
x by itself.
You're the one who suggested we divide by x on that last problem, right?
Yeah.
And I didn't?
Yeah.
Do you see
Yeah, I
why now?
realize why, yeah.
Okay.
I
Do you see
remember,
why now?
yeah.
Okay.
Yeah, I see why.
I couldn't quite prepare you for that then, but now you can see why. Almost everyone is here, I
I was
believe.
stuck.
I can't see why yet, it's not by itself.
Yeah, it's not by
I mean, I
itself
can
yet.
divide it by two,
Hmm?
but that just opens up a whole nother can of worms.
No, because then you have.
Where?
by
How?
itself, isn't that
Where?
what it was?
With the
No.
Y's? Okay, so what are you going to do?
Oh, yeah, because then you just divide
You're,
by one.
you're on the right
No,
track.
then you divide it- No, then you're using a y on the right side too.
I know.
Is everyone pretty much like at the same
Yeah.
spot?
Yeah, it's about that spot.
Well, no,
Well, I added
what
it.
happens is
The y can't just commit to the same spot.
You're trying to solve for?
This is like, yes, this is like Sudoku.
Trying to solve for y. So, okay, so first thing, if you divide by 2, you get y.
Yeah, but you
Then
still
you
have a
have-
Y on the other side.
But you still have y over there. So here's the problem with that. In order to know what y is, you still have to know what y is. So that's like a circular argument. Like a, like you can't know y unless you know y.
Yeah, exactly.
Why not?
Okay.
Because I said so.
Solve for y. Anyone see it?
Divide by 3.
What do you got?
Is it x over 3x minus
X over. Yes, how do you do that?
I put the x on the other side and I put the y with the...
So what you were trying to solve for, y, you got them all on one side. Everything that didn't have y, you got to the other side. Yeah, let's try that.
How do you do that?
Just move things around. Add and subtract. So we're going to move the x to the right and move the 2y to the left. Now you can't combine them together because they're not like terms,
Yeah, I'm
but you can at least do that. GCF. That's what you said. Yep. GCF. You can factor out a y now on the left side. They both have a y, right? So pull the y. 3x minus 2 equals x. And now divide through by the 3x minus 2.
Oh, I feel such an idiot now.
I think that's like everyone in here right now. For the most part.
Isn't that what it was supposed to be? Yes.
F inverse of x.
Yeah, sorry, yes. I wasn't done.
He wasn't done. Calm down.
I had boxed it, but I intended on coming back over here and putting F inverse there.
Let him take a drink first. Jeez.
All right, now this is a problem I like to give on tests. And I always warn the class about it, and then I do it and people still get lost on it. Just remember that what you're going to have is you're going to have the y you're trying to solve for appearing on both sides of the equation. So you got to move it all the y's to one side, everything that doesn't have y to the other, and then pull the y out as a GCF, and then divide through by what's left, and you're
I
done.
didn't think about the GCF part. I was
Yeah.
like, what am I looking at?
This will help you in Cal 1 also. Anytime you're trying to solve something in a complicated equation, try and get that on one side. Even if there's a bunch of other crap with it, just get all that stuff to one side, everything that doesn't involve that to the other side. And then try and GCF it out. All right. How are we doing on time here? Good? All right, very quickly for me, do one more. Find the inverse of that for me, please. That shouldn't take you but no more than 3 minutes. Find the inverse. It is
X minus 3 over 2 equals that thing.
okay. Now, on this x minus 3 over 2, is that the same? Can I split it into two fractions like that?
Yeah.
Yes? Okay. Now, the reason I did that is because If I look at it as 1/2 x minus 3 halves, that's a line, right? Y equals mx plus b. And this one is a line also, 2x plus 3. What I'd like to do is just graph these real quick. Now, I'd like to do a pretty accurate graph. So I'm going to do, let's do the f of x. I'm going to do this one in blue. That has a y-intercept of 3. And then from there, to get to another point on the graph, up to right 1, slope is 2, up to right 1, something like this. And then the other one I'll do in red. And this should not be news to you. I told you what was going to happen last class when we graphed these. Do you remember at the end? So there's going to be like a reflection, a mirror image. But let's just double check it here. This one has a y-intercept of -3 halves, which is, that's -1, -2. -3 halves is -1.5, so it's about right here. And then to get to a point on that line, I go up 1 to the right 2. So up 1 should take me here. To the right 2 should take me here. Something like this.
That way it mirrors over x equals y.
Mm-hmm. And I'm going to go and do a little bit more here. I'm going to write out a t-table for this function f. If I plug in 0, I get what? 3. If I plug in 1, what do I get? 5. 2 and 7. Good enough, okay? If I plotted these points, this is the point right here, 3, 0. This is the point 1, 5. The next point up here would be 2, 7. Now, let me do a quick little t-table for the red one. X in its inverse. Pardon? Yeah, why don't I just use the opposites? Like if I plug in 3 here, what should I get? 0, and you can check it yourself. 3 times 1/2 is 3 halves minus 3 halves, that's 0. If I plug in 5, 5 halves minus 3 halves is 2 halves, that's 1, so you get 1. And then, 7, 2. So we have the point 3, 0, that's here. The point 5, 1, which is out here, and the point 7, 2, which is here. Five, 1, 7, 2. I'm only doing this to help solidify what I'm going to do when I summarize all this. So now come in here and let's draw the identity function. The identity is the function y equals x.
I think I only just now realized that you put 3, 0 instead of 0, 3 on the blue line, the first point that you did.
Did I put, oh yeah, I got that backwards, thank you. 0, 3. If I draw the identity, then you reflect it, then you get the other function. So a function is always, the inverse of a function is always the reflection of the original function over the identity. Always. And it's just because the coordinates change places, right? This one, instead of being 3, 0, becomes 0, 3. So that point goes straight across, becomes that. 5, 1 goes straight across, becomes 1, 5. 7, 2 straight across. So you see how everything just mirrors over like that? Okay. So I don't think I'll write that down. Is it okay? You got that in the brain somewhere? All right. So this is going to be vital to us when it comes to graphing the next two types of functions, which are exponential and logarithmic functions. All right? This idea. Because the way we're going to do it is this. We're going to graph a function. We're going to graph these functions called exponential functions. And the way we're going to do it is by a t-table, like the old school way. All right? And then we're going to talk about these things called log functions. And it turns out that the log functions are the inverses of the exponential functions. So to graph a log function, what I'm going to have you do is graph the exponential function and then switch the coordinates. And then you're done, if that makes sense. So it's like if I wanted you to graph this guy, but let's just say that was too ugly to look at, you would graph this guy, or not even graph it, you would just make a t-table of that guy, flip these over, plot these, and that would be the graph of this, right? So that's the way we're going to do it. We're going to have a function that's hard to graph, so we're going to take one that's easier to graph, t-table, flip, and then we're done.
This strategy that we're doing, I presume it's going to save, like in later process, it's going to be saving a lot of time versus just a little right now.
Of doing what?
Like if just additional unnecessary work.
You mean what I just said about like to graph the log, we'll graph the exponential and switch? I just think it's easier that way.
Okay.
Yeah. Okay, we have about 20 minutes. See if there's any loose ends in this section I want to tie up. One last thing, it'll take me 5 minutes tops, and then I'm going to cut you loose so you can go enjoy your weekend. I'll start it with a quick visual example of this. If I take a function f of x equals x squared, and I restrict the x greater than or equal to 0, does that function have an inverse? Yes?
Oh, yeah.
No?
If you're restricting it.
I am restricting it, yes.
If you don't restrict it.
If I don't, then okay. So if I were to try and talk about this function, f, I can plug any number into this, can't I? Any real number? I can square any real number, but I'm restricting you to positives, right? Okay, so I'm going to say positive numbers over here, or 0. Yes? Try and think of how to do this. I'll just put x greater than or equal to 0. How about that? Yes? Okay, this over here we call the domain of f, right? This is the domain of f. When it goes through this function, f, it spits out numbers, doesn't it? It spits out what types of numbers? If I square, right, it's going to spit out, again, positive numbers or possibly 0.
Yes.
If I plug in 0, it's going to spit out 0. So the y's that come out of here are greater than or equal to 0. Still with me? This group of numbers right here, everything that comes out, is called the range. I'll put ran of f. That's the range of f. So imagine that there's some negative numbers sitting over here, -3, -4, -10. Those numbers never get touched by this, right? So the range, you may have a big set of numbers here, which could be all real numbers. The range of f is only the positive numbers over here, right? When you go backwards, this function has an inverse, doesn't it? If I restricted it. If we go backwards, this should take us back into here, shouldn't it? Into the positive numbers. This is the inverse function that does it. would you agree with me, if I draw the picture this way, that the domain of f is equal to the range of f inverse, and the range of f is equal to the domain of f inverse? Okay. Yes, you agree with that? I agree. This is the domain of f. That goes into f and it spits out its range. But when you go backwards, you go from here to here, that range of f becomes the domain of the inverse. And then it spits out, the f inverse spits out this, which is the domain of f. That's the relationship between domains and ranges of functions and their inverses. You always have that relationship. That'll be helpful in later classes. Okay, I think that's it. We don't have enough time to start exponential functions. Oh, calculators. Make sure you bring your calculators next week and from here on out. Not your cell phones. The calculator you would use on a test, because I don't want you to sit there and be like, first day you ever use your calculator is the day of the exam. Yes?
Scientific still okay right now?
Scientific or graphing. I don't mind graphing also. But you need at least the scientific. All right, everyone, have a good weekend. You should be able to do the homework on the schedule again.
This class, it's a lot easier.
Then what?
Like, it's a lot more difficult in the beginning than